So we'll take octahedral, we have done octahedral complex, we'll take tetrahedral and square planar complex. Square planar complexes. So splitting pattern we had already gone through. This is reverse to that of the octahedral complex. That is, E comes first, then comes T2 orbital. Right? E comes first, then comes T2 orbital. Square planar, the splitting pattern is basically derived from the octahedral complex. We'll take one of the example, that is NiCl4, NiCl4 2 minus, or K2NiCl4. This is the complex, for instance, given to you. You need to predict first whether it is a tetrahedral or the square planar complex. I will straight away say it is a tetrahedral complex. Right? Tetrahedral complex. Why? Because square planar complex happens with the 3D8 system. That is, this is 3D8 system. With the D8 system, 3D8, 4D8 or 5D8. That is, alongside, important thing is, for the 3D8 series, we need to have strong ligand for have a square planar complex. If it is a weak ligand, we will have a tetrahedral complex. This I had gone through. This is a shortcut I had given already. Alright, square planar complex happens only and only with the D8 system. If along with one more thing has to be remembered is 4D8 and 5D8 doesn't matter whether it is a strong ligand or the weak ligand. For the 3D8 system, you need to have a strong ligand for getting the square planar complex. NiCl4, K2NiCl4, it's a tetrahedral complex, students. Right? Since it is a tetrahedral complex, straight away we can say the hybridization is sp3. Hybridization is sp3, right? Hybridization sp3, and the splitting is very easy for us. That is, the splitting is ET2, right? ET2. It's anyhow, it's a the tetrahedral complex. Obviously, will be having delta naught will be lesser than the pairing energy, and hence the electronic configuration is, how many electrons will be having, students? It's a D8 system. That is 3D8 4s2. It's 3D8 system, right? 3D8 system. 8 electrons we have. That is E. Right, initially we will fill 2 electrons here, 3 electrons here, again we have to fill here, that is E4, T24. This is the electronic configuration of our 3D8 system, that is, right, that is E4, right, and T2 means we have 3 pairs, 1, 2, 3 and 4, right. So this is the electronic configuration, that is E4, T2, 4, right. That means how many unpaired electrons we are having? Number of unpaired electrons, how many we are having? 2 unpaired electrons. So magnetic property will be it's paramagnetic, because we have 2 unpaired electrons. It's paramagnetic, right? It's paramagnetic. So magnetic moment will be is equal to square root of n into n plus 2, that is square root of 2 into 2 plus 1, 2 plus 2, 2 into 2 plus 2, whatever we had done earlier, n into n plus 2, right? So 2 into 2 plus 2, that is 2 into 2 plus 2 is how much it is? 4 into 2, that is 8, square root of 8 is near to 9. That means I can write approximately it is 2.89 or 2.89 Bohr magneton, approximately 2.88 to 2.89 Bohr magneton, right? So this is the magnetic moment of the complex NiCl4 2 minus, right? It's a tetrahedral complex, number of unpaired electrons we got it. CFSE also can be calculated. What is the CFSE value for this, students? Crystal field stabilization energy will be, how much it is? E orbital 4 electrons, 4 into how much it is? Minus 0.6 delta naught plus 4 into plus 0.4 delta naught. Each electron going to the T2 orbital will be destabilized by 0.4. It is stabilized by 0.6. That means minus 2.4 delta naught plus 1.6 delta naught, that is minus 0.8 delta naught, or it is minus 8 dq is the crystal field stabilization energy of this particular complex. This particular complex, the crystal field stabilization energy. So there is no question of outer orbital, inner orbital the complex come into the picture, because only one hybridization will be sp3. There is no involvement of the inner or the outer d orbital for hybridization. So this is about this complex, student, that is K2NiCl4. Let us take one more complex, that is same thing, that is with instead of chlorine we will take cyanide as a ligand. NiCN 4 times, NiCN 4 times, 2 minus is the complex, or you can write it as K2NiCN4. Again the Ni plus 2 it is, that is it is a 3D8 system. Now you check the the ligand, nature of the ligand. Ligand is a strong ligand. Strong ligand means obviously the complex is a square planar complex. Square planar complex. D8 system, strong ligand, square planar complex. Square planar complex, the hybridization is obviously dsp2. Inner d orbital will obviously involved. So dsp2 moment you speak, that is inner d orbital will be involved, and the electronic configuration important electronic configuration will be how it goes. We have a lowest one dzx, the yz orbital will be having 2 electrons will be taken. Next comes dz square orbital which takes 2 electron. Next comes, what is the orbital which comes here? This is approximately equal, right? Then next comes dxy orbital, then comes dz square orbital, sorry, not dz square, dx square minus y square orbital, right? So 2 plus 2 plus, this is approximately equal, 2 plus 2 plus 2, and this is also electron take. So the last orbital is empty for us. Last orbital is empty. That means, see, it's a very important aspect, students, make a note of it. Say, square planar complex will be made mostly by the D8 system. When you are having the D8 system, strong ligand, and it will be done by only the D8 system, and hence till dxy orbital it will always be filled, and the last orbital, that is dx square minus or y square orbital will always be empty as far as square planar complex is considered. Or in other words, can I say all square planar complexes, because there is no unpaired electron, all square planar complexes are diamagnetic in nature. Very simple. You can simply predict the answer. Whenever you are having a square planar complex, you just predict it is a diamagnetic one. That means magnetic moment, if at all they are asking, magnetic moment is equal to 0. Got it, right? There is an exception is there, students, here. Remember, exception, that is cuprammonium sulfate, Cu ammonia 4 times SO4, cuprammonium sulfate. Although we anticipate it to be a square, the tetrahedral complex, this is a square planar complex. This is the exception we are having. Remember, very important one, since it is an exception because the system which is present here is copper plus 2, that means it is a D9 system. All D8 systems are only exhibiting the square planar complex. Only and only exception we are having is copper plus 2, cuprammonium sulfate, which is a D9 system, but it is a square planar complex. Since it is a D9 system, 2 plus 2 plus 2 plus 2, one more electron left out, and the last electron go to the dx square minus y square orbital. This is the electronic configuration of this particular complex. This particular complex, this is the electronic configuration, and this has one unpaired electron. Very important. It has one unpaired electron, and hence it is a paramagnetic one. Several times they have asked this particular complex, student, in the competitive examination. Keep this in mind very clearly. All square planar complex will be made by D8 system. Since D8 system will be made, last orbital will always be empty, rest of all orbital will be having paired electron. It will always be diamagnetic. Magnetic moment is 0, but there is an exception, which is a cuprammonium sulfate, which is square planar complex, D9 system, and hence it's supposed to be a paramagnetic because last electron will go to the dx square minus pi square orbital. Right. So this is about our this nickel tetracyanide complex. And what else has to be predicted in this? So we have magnetic moment has been predicted, that is hybridization geometry. Magnetic moment has been predicted. Stability, it is highly stable one, highly stable, right? Highly stable, all square planar complexes are highly stable, and alongside its magnetic property being predicted, alongside the name of the complex, you know how to name it, potassium tetracyanonickelate 2, potassium tetracyanonickelate 2. So this is how the the properties of the square planar complex, that is nickel tetracyanide, can be predicted.